Okay, hi everyone. So this question is from statistics normal distribution. The question says the weights of packets of a certain type of biscuit are normally distributed with mean 400 grams and a standard deviation of sigma. So in part I, it says in a random sample of 6,000 packets of this type of biscuit, 225 packets weighed more than 410. So that's the relative frequency. So we could say the probability of, if you say that weight of a randomly selected packet is x, then you can say the probability of x being greater than 410 grams is equal to 225 over 6,000. So let us work this off. So I'm going to start with this. X is the weight of one biscuit packet, and x is normally distributed with 400 comma sigma square, and probability of x greater than 410 is equal to 225 over 6,000. That's the ratio. So when we convert this into decimals, you shall get a value of 0.0375. So I can normalize this. So probability of z greater than 410 minus 400 over sigma is equal to 0.0375. So probability of z less than 410 minus 400 is 10 divided by sigma is equal to 1 minus 0.0375, because here it is greater than this value, so less than that should be 1 minus this, which means z less than 10 over sigma is equal to 0.9625. Now we need to go check in the normal table which z value is equal to 0.9625. Let me quickly get into the normal table. So you can see 0.9625 is at 1.78. It's over here. So 1.78 is that value gives you 0.9625. So 10 over sigma is 1.78, which means sigma is equal to 10 over 1.78. So this value is equal to 5.62. So which means our standard deviation sigma is equal to 5.62, correct to two significant figures. So that's my part I. Now let's get into this next part of the question. So here's the second part of the question. It says in a random sample of 500 packets of this type of biscuit, how many packets would you expect to find with weights that are more than 1.5 standard deviations from the mean? So this phrase is very important. 1.5 standard deviation means 1.5 times sigma. From the mean means it should be away from the mean with this distance. Should be away from the mean this distance. So that could be either in the positive direction or in the negative direction. So let me show you the diagram. Let's say this is the x-axis and here's what we call the mean, mu, and this will be mu plus 1.5 sigma. So this is the distance of 1.5 times standard deviation away from the mean. Otherwise this should be mu minus 1.5 sigma. So this is also 1.5 sigma away from the mean. So it should be probability of x greater than mu plus 1.5 sigma, or probability of x less than mu minus 1.5 sigma. It should be this region which is away from mu plus 1.5 sigma, or else it should be this region. So it's this way or it's this way. So this, if you normalize, it's going to be z greater than mu plus 1.5 sigma minus mu over sigma plus, so or indicates we need to add the two probabilities, and this one should be z less than mu minus 1.5 sigma minus mu over sigma. So z greater than 1.5 plus probability of z less than minus 1.5. So let me explain the simplification here. Mu cancels off, then sigma and this sigma should cancel off similarly. So we get this final result. So if I explain this using a diagram, here is my 0, this is minus 1.5, this is plus 1.5. So they want you to find these two regions. So this region is equal to twice of 1 minus probability of z less than 1.5. So this is equal to 2 minus 2 times probability of z less than 1.5. So let me check the normal table once again. So 1.5 is 0.9332. You can see this at the last row, or else the first row over here, 9332. So that's going to be 2 minus 0.1864, which is 0.1336 is the final answer. This is the probability that a randomly selected biscuit packet's weight should be more than 1.5 times standard deviation away from the mean. Could be 1.5 times standard deviation more than the mean or less than the mean. That's what I mean. And then the number of packets that they ask you to find, which is, they say how many packets would you expect. So that's going to be the expected value of this. So number of packets should be NP, which is N is 500 into 0.1336. So that value should be equal to 66.8. So if you round it up, I would say 67 packets. Hope you understand.